Hello class, so welcome to Advanced Engineering Physics or ES12, and today's topic is Thermodynamic System and Control Volume. So before we proceed to that, let us define what is thermodynamics. So thermodynamics comes from the Greek thermi, meaning heat, and dynamis, meaning power. It is the science that deals with the conversion of energy from one form to another. Again, we deals with the conversion of energy. So the direction of the flow of heat and the availability of the energy to do work. So it makes sense because field of thermodynamics is concerned with the science of energy, now focusing on energy storage and energy conversion processes. So we will study on the effects of the different substances as we may expose a mass to heating or cooling or to the volumetric compression or expansion. So during the process, we are transferring energy into or out of the mass. So it changes its condition expressed by properties such as temperature, pressure, and volume. No? So we use several processes similar to these in our daily lives. So like we heat water for coffee, we freeze or cold water to make ice cubes or cold water, and then or any other similar things that we do in our daily lives, no? And then in nature, water evaporates from rivers or rivers or lakes and mixes it with air when the wind will where the wind will transport it, and later the water drops out the air as either rain as the liquid water or snow as the solid water. So we study processes in detail, so focuses on the situations that are physically simple and yet typical of real life situations in industry or in nature. So before considering the applications of the theory, we will cover a few basic concepts and definitions for our analysis and review some materials from physics and chemistry that we will use or we will need throughout the throughout this course. So by that, let us define first what is thermodynamic system. So thermodynamic system is a device or combination of devices containing a quantity of matter that is being studied. And the another definition of that one is it that is refers to a definite quantity of matter, most often contained with some closed surface chosen for study. So before we go deeper on the discussion on thermodynamic system, we should define first the control volume, since it is one of the requirements for us to identify what thermodynamic system is that system referring to. No? Because we need to have a closed and the surface that is chosen for the study. So first, control volume is a fixed region or space enclosed in a boundary called control surface that separates the system and the surroundings. So it is used to study systems that has mass and energy flows in and out of it. So again, it is used to study systems. So that's why we need to define it first. So next is we have the types of the thermodynamic systems. So we have three types. We have the open, we have the closed, and the isolated systems. So let's define first the open system. Open system or steady flow is the systems are able to exchange energy, heat, and work and mass across the system boundary. So as you can see in this illustration, so we have the system and the mass can in and out, and as well as the energy also. So that is the difference between the open system. And the examples of the open system is the electric fan, we have the washing machine, we have the kettle, and we have the water pump. So let's take the electric fan as for the example. So the electric or the energy that flows to the motor of the fan as it as the blade rotates, now the energy um, downs and then it dissipates throughout the system. So next, we define the closed system. Closed system or non-flow system are systems are able to exchange energy. We have the heat or and work and across the system's boundary, but not the mass. So as you can see in this illustration, mass cannot in or out or flow through in or out of the system, while the energy can. So that would be for the closed system. Examples of the closed system is the TV, the phone, and the light bulb, and we also have the wheels. Now, so let's take the bulb for example. So the energy that flows in through the bulb will be dissipates through the system through heat, no? So ang yang energy is most low or low through heat and the lights that was dissipated through the bulb, no? Next, in our thermodynamic system is the isolated system. Isolated system is are very isolated from the environment. There is no exchange of heat, work, or mass across the system boundaries. So as you can see in this illustration, in the system, the mass and the energy are both cannot flow in or out of the system. That is why it's called isolated. No? So, for example, we have the thermos. So, if we store hot water in the thermos, and then if that was a perfect isolated system, the hot water or the temperature of the water remains constant in the period of time. No, so dili siya mo bubugnaw and so on. No, so the energy and the mass in the system will not is in isolated, no, or isolated throughout the surroundings. The perfect example for the isolated system is the universe, of course, no. So in a real world, only sample system that we can actually label as an isolated system is the universe. Here we have the systems using control volume. So we have here an example, the boiler, and we also have here the condenser. So next topic would be the macroscopic versus the microscopic points of view, and I will be giving sample videos or lecture videos on it. So I hope that would be all clear. So see you at the next topic.